This is the forces lesson 5 video. This is on resultant force, mass and acceleration. The objectives are to recall and utilise Newton's second law and to explain what unbalanced forces do to objects in terms of acceleration. So, equation first off, the force, mass and acceleration object are related by the equation. Force is equal to mass times acceleration, or F equals ma. Force is measured in newtons, mass is measured in kilograms, and acceleration is measured in meters per second squared. If you want to get that down, just pause the video. At any point to make some notes, just pause and then just continue when you're ready. So let's get straight into it. So I'm going to show this as an example, but if you're confident with these types of equations now, you can just have a go and then obviously check the answer. So this one says calculate the force required to cause a car of mass 1200 kilograms to accelerate by 5 meters per second squared. So it's quite a straightforward one. So we're just going to utilise the equation. So F equals ma. So force is equal to mass times acceleration. And then just put the numbers in. So the mass is 1200 kilograms multiplied by 5 meters per second squared. 1200 times 5 is 6,000 newtons. So as you can see, we've done the equation, the working out, answer with a unit. That's what the examiner wants to see. The examiner wants to see clear working out and show that you know what you're doing. Let's have a go at this one then. Pretty straightforward. Then I'll go for the answers. So this one is calculate the acceleration produced by a force of 200 newtons on a mass of 4 kilograms. So once again, I'm just going to write the equation. Oops, F equals ma. It's just a matter of putting the numbers in. So the force is 200 equals the mass is 4 kilograms multiplied by the acceleration. So just 4a. And if you're in a maths lesson, your maths teacher might just say, I want you to make A the subject, which is what we're going to do. So to make A the subject, to get it on its own, we need to get rid of the, anything else that's attached to it. So in this instance, we've got a multiply by 4. So to move a multiply by 4 to the other side of the equation, we do the opposite. And the opposite operation of timesing by 4 is dividing by 4. So we're going to do 200 divided by 4 is equal to the acceleration. And that gives an acceleration of 50 meters per second squared. So if you got that, well done. Let's move on to the next one. So be a bit careful with this one. So you want to pause and have a go. So calculate the acceleration produced by a force of, this is 500 Nn or mn. And if you've not seen that before, it might be familiar a little bit, because if I said what is 500, or if I said what is this, you would know that that's 500 millimeters. And you should know that there are 1,000 millimeters in a meter. So 500 millimeters will be half a meter. So to do that, you just divide by 1,000. It's the same thing with this one. So 500 millinewtons is obviously 0.5 newtons, but you might want to divide by 1,000 depending on what number you get. So if you do 500 divided by 1,000, that'll give you the force that's required, which is 0.5 newtons. So let's write the equation. So that's F equals ma. So the force is 0.5 newtons equals, and the mass, we've got to be careful with this one as well, because this is 300 grams. And if you remember, you should know that from maths that there are 1,000 grams in a kilogram, so we have to divide this one by 1,000 as well. So 300 divided by 1,000 is 0.3. So we've got 0.5 equals 0.3 times A. And it's just the same process as last time. So we need A on its own, make it the subject. So we need to get rid of a times 0.3. So we can just do 0.5 divided by 0.3 to give us the acceleration. And that gives us an acceleration, it's 1.6 recurring essentially, or 1.7 to two significant figures, in the unit meters per second squared. So hopefully that one went okay. So let's have a go at this one. Bit trickier. Hopefully you've covered something else that you might need, but you might be able to figure it out anyway. But let's have a go, and then I'll take you through the answer. So this one says calculate the force. So we need the force that accelerates a mass of 300 kilograms from rest to 6 meters per second in 3 seconds. So if you're a bit confused by this one, you might write F equals ma. So force is mass times acceleration. So we've got the mass, the 300 kilograms, but we need the acceleration. So what we've got is we've got two speeds. So we've got from rest to 6. So we've got a change in speed or change in velocity, and we've got a time taken. So there's another equation. Acceleration. If you haven't covered this, now you have. Normally you cover acceleration before you do Newton's second law at school. So change in velocity over the change in time. If you're not sure what this triangle is, that just means change. It's a Greek letter delta. So I'll write this down just in case. Capital delta, and it just means change. So to get the acceleration, we need to do the change in velocity. So the change in velocity is from rest to 6, so the change is 6, divided by a change in time of 3. So the acceleration is 2 meters per second squared. And now we can go back to our original equation and finish this off. So the force is equal to the mass, which is 300, multiplied by the acceleration, which is 2. So the force is simply 600 newtons. If you got that, really good, well done. So let's move on. So to finish, if you want to pause the video, have a go at this one. And then I'll go through the answers. So the first one is, so we need the force. Just put a little bit of working out in here. So it's F equals mass times acceleration. So that's simply 4 kilograms multiplied by 6 meters per second squared. So 4 times 6, you should have got 24 newtons. So let's have a look at the next one. So F equals ma. So the force is 200 equals the mass, which we're looking for, times 5. So we need to rearrange, so that should just be 200 divided by 5 will give you the mass, which is 40 kilograms. Right, let's have a look at the next one. So acceleration, not much room for this one, pop it in here. So F equals ma. So the force is 600 equals 30 kilograms multiplied by the acceleration. So to get the acceleration, same again, done this a few times now, 600 divided by 30. And 600 divided by 30 would give you 20 meters per second squared. So look at the next one. It's got to be a bit careful with this one because we've got 5 grams. So we need to divide that by 1,000, remember. So that is 0.005 kilograms. Then it's just F equals ma. Just got to simply multiply these together. So it's 0.005 multiplied by 400. So if you put that in your calculator, you'll get a force of 2 newtons. Then the last one, same again. Just got to be careful. So we've got 100 grams, so we need to divide that by 1,000, so that gives us 0.1 kilograms. Then it's just F equals ma. I'm going to put some working out at the bottom here. So F equals ma. So it's 5 equals 0.1 kilograms multiplied by the acceleration. So 5 divided by 0.1 gives the acceleration, which is 50 meters per second squared. The question, however, is asked for an answer in centimeters per second squared. So we need to convert that 50 meters into centimeters. So we need to multiply by 100. So 50 times 100 is 5,000 centimeters per second squared. Hopefully you found that helpful and pretty straightforward, and obviously you did well. Thanks for watching, and I'll see you at the next video.